All right, let's go. Let's get into it. We're going to talk about coterminal angles. Coterminal angles. So coterminal angles are any angles that terminate at the same angle between 0 and 360 degrees. Let me give you an example. How about 0? Wow. How about 0 and 360 degrees? They terminate at the same spot. So we always start on the positive x-axis. That's 0 degrees. Now, if we're to go around in a circle and end up back where we started, that would be 360 degrees. Thus, that means that if sine of 0 is equal to 0, sine of 360 degrees is also equal to 0. Because trig functions don't care how many times you spin around in a circle. They only care where you end up. And cosine of 360 would still be equal to 1, just like what's up above. Now, I can keep playing this game. I can keep going around in circles. And then I can call that this angle here is now a 720. Gone around in the circle twice. Thus, sine of 720 is still 0. Cosine of 720 is equal to 1. Those are what we call coterminal angles. And I can keep playing that game. We can go 360, 720. Add another 360. You get 1080. Add one more 360. You get 1440. Add another one. You get 1800. They all give you the same gosh darn answer because they're coterminal. So similarly, from 90 degrees, does anybody know 90 degrees? So if we were to have an angle here at 90 degrees, right, makes a right angle. 90 degrees, we start on the positive x-axis. This is 90. Can you figure out a coterminal angle to 90 degrees? What's coterminal to 90 degrees? You add 360 to it. 90 plus 360 is actually equal to 450. I just took 360 and added another 90. So we're thinking, well, we could do this for a 90, or we could go all the way around in a circle and end up right back there. Meaning that if sine of 90 degrees is equal to 1, then sine of 450 is also equal to 1. Similarly, cosine of 450 would be the same thing as cosine of 90, which would be 0. These are what we call coterminal angles. Trig functions don't care how many times you spin around in a circle. They only end up caring where you point to, where you end up. Now I can keep playing this game over and over and over. Now I'm just going to kind of run through it and be like, if you were to add 360 to 180, you get 540. If you were to add 360 to 270, you would get 630. So those are what we call coterminal angles. They terminate at the same spot, but like 630 degrees had to spin around a lot more than 270, but they still ended up at the same spot. I always think of board sports like snowboarding or skateboarding or something like that. It doesn't really matter how many times you spin around in a circle. You just gotta land that trick by pointing downhill. Whether you land front side or back side. Sorry, I better shut up about board sports. I get a little excited about that. Yeah, so there's some coterminal angles. But let's not lose sight of the fact that we also have, I kind of jumped over this. I keep talking about the positive direction. That's the positive direction when we're taking an angle. But what happens if we go in the negative direction? What if we went this way? And we said that this is actually equal to negative 90 degrees. So negative 90 degrees, 270, and 630 degrees, they're all coterminal. Which means if I write over here, I find the cosine of 270, the sine of 270, I'm like, well, I know my answers. I already know my answers. Say sine of negative 90 degrees. Since it's coterminal to 270, it still needs to equal negative 1. Cosine of negative 90 degrees. Well, since cosine of 270 is 0 and negative 90 and 270 are coterminal, cosine of negative 90 will also equal 0. And that's our game. So we're not memorizing everything, but we're going to memorize everything in between 0 and 360 as far as like angles go. We're going to be great with that. Sine, cosine, between 0 and 360. But I'm sorry, I've been misspeaking to you. What about radians? Dun, dun, dun. I'm trying to do a lot of degrees at the beginning. So we can get some understanding going, right? Because I imagine you understand 90 degrees better than pi over 2. So I want to cheat here, and I want to change all these up. Oh, I just changed sine of 0 and cosine of 0 into radians, right? So this is 0 radians. And if you go around in the circle, that's 2 pi. Thus, these are coterminal, whether you go around once or you don't move at all. So that means sine of 2 pi is equal to 0. Cosine of 2 pi is equal to 1. But where does it see a lot of value out of this? It's going to be at the 90s and the 270s when it has to do with radians. Just taking all this stuff out and going, well, sine of 90, this is, or 90 degrees, that's pi over 2. 180 degrees, that's pi. 270, that's 3 pi over 2. So we have sine of pi over 2 is equal to 1. Cosine of pi over 2 is equal to 0. So let's start thinking about our 90 degree, our pi over 2 angle. That equals 1. But what if we were to go around, all the way around in the circle, come back where we started? Well, this angle is just going to be pi over 2 plus 2 pi. We're just adding 2 pi to it. We're adding 360. We're just going around in a circle. And I'm going to write that down. I'm just going to jump the step and say that's actually 5 pi over 2. So we could say that sine of 5 pi over 2 is coterminal. That's coterminal. 5 pi over 2 and pi over 2 are coterminal, so that's got to equal 1. And cosine of 5 pi over 2 is equal to 0. Let me change all my other angles, and then we'll be done with this one. Hopefully this is starting to make sense. Some of y'all already kind of know some of this because some of us see trig in high school, or maybe a previous class. Maybe you took this class before and you failed. And you're like, I already know this stuff. Happens. One of my best tutors ever. She failed the class, came back and dominated and tutored. So don't let one failure define you if you could. So if we're to add 2 pi to pi to go around another circle, that'd be 3 pi. If we're going to add another 2 pi to 3 pi over 2, that's 4 pi over 2 plus 3 pi over 2, that's 7 pi over 2. So those are coterminal as well. And I know a lot of us, if you don't like fractions, you're like, this sucks, I don't like this stuff. There's going to be a trick. You will see soon why radians are vastly superior. Dare I say, easier. Not at first, but soon. Most students fight like hell at the end of the class to never use degrees. They only want to use radians. Most. Oh. Just typically the ones that pass. Is this making sense? That if these angles, if you spin around in a circle, you still end up back where you started. So these are coterminal, meaning we get the same values of sine and cosine. Now, please note, I'm not writing down anything about tangent, cosecant, secant, or cotangent. Screw them for now. Be pro with sine and cosine. Can you get all your values of sine and cosine? For 0, pi over 2, pi. 3 pi over 2, 2 pi. And any addition by spinning around more in a circle. Please look before we go. Cosine, whenever it has a pi over 2 in its bottom, it's always equal to 0. Whenever there's a pi up top and a 2 down below, it's always equal to 0. Look, 3 pi over 2, 0. 7 pi over 2, 0. It looks like whenever there's a pi up top and a 2 down below, cosine will always equal 0. And it seems like if there's no denominator, like 0 pies, 1 pi, 2 pi, 3 pi, we could get to 4 pi. Sine's always equal to 0. I don't know, tricks. Instead of memorizing everything, just having some quick ways to get through problems. So it is what it is. So we're going to start building some triangles soon. I'll show you how we're not going to really deal with this whole circle idea. We're going to deal with triangles. So we're going to build some stuff up. We're going to start talking about some values, and then you're going to need to get these values memorized up. Don't worry, it's only 5 numbers you're going to have to memorize. 5 numbers. Can you memorize 5 numbers? I think you can memorize 5 numbers. But I'm minimizing because you're going to have to know the angles too. I will see you in the next video where we make some gosh darn triangles, getting away from this circular stuff. All right, take it easy.